Greetings fellow geeks and welcome to another Geek Moment video. My name's Chris and today we're looking at Cree's new silicon carbide MOSFET. Our particular MOSFET is rated at 20 amps and 1200 volts and is designed for very high-speed switching applications. Our particular application, as you can see, is a Tesla coil. We're driving this with 4 Cree SiCFETs in an H-bridge configuration. We're also using 4 Cree silicon carbide diodes as freewheeling diodes in the H-bridge. They're being driven by 4 gate drivers here, which are powered by isolated power supplies. These are DC to DC isolated power supplies, 2 watts apiece. Right below it we have some combinational logic and dead time generation. Underneath this there is a voltage to PWM generator, and the voltage is coming from electric guitar. And we're going to play some guitar for you here and then we'll talk some more about it. So we've asked my good friend Ben to come play for us some. Ben and I play together in a band, had in a little warehouse behind a gas station here in town every Sunday morning. Ben's guitar, as it creates audio, that audio signal is converted into a PWM signal that's mixed with the combinational logic into 4 gate drive signals. It's mixed with the high frequency oscillator. It's oscillating about 450 kilohertz. That's that high frequency switching we were talking about with these Cree SiCFETs. Those 4 signals are then fed into the H-bridge, which is powered by 170 volts DC. It's actually running through our Variac, rectified about 170 volts DC. That voltage would not be enough to create a lightning coming out of the top of this thing were it not for the natural resonance of the coil. And it's that 450 kilohertz that we had to tune to the resonance of this coil. The turns ratio, we got about 9 turns here and about 1200 turns on the secondary. And so again, that voltage wouldn't be enough to create the lightning. The arcs we're getting out of here, probably 4 or 5 inches or so. We estimate somewhere between 50 and 100,000 volts. We've got a fluorescent light bulb sitting behind here, and that'll light up. There's nothing connected on either end, and so it's just the electrical field induced by the coil here that causes that to light up. You'll see that in a second. The sound you're going to hear is actually caused by the air expanding as it's heated up by the power delivered into the air. It then collapses according to that PWM signal, and it's that rapid expansion and collapse that causes sound waves to be propelled out, just as if it were a speaker pushing that air forward and backwards towards you. So Ben, you want to play some for us? We'll see how this thing works. Awesome. So as you can tell, we're in a little different location here. This is a warehouse provided by our good friend Jamie, who you've seen in some other Geek Moment videos. We didn't want to do this at Digi-Key, all this voltage. We didn't want it to cause any problems with the sensitive computer equipment at the shop. So we came out here today, and I forgot what I was going to say next.
I get to play more.
You get to play more. Sweet. Why don't you play for some more? You guys go check out these silicon carbide MOSFETs at Digi-Key.com, and we'll see you next time.